Oh. Okay, sorry. Through the Black Hills, the variable x represents the time the cyclist has been riding, and y represents the cyclist's distance in kilometers from Rapid City. Not all the cyclists started their ride at Rapid City, but all of them left at the same time and are riding in the same direction. So, page 52 has this lovely space for you guys to make a graph of all 4 equations representing our 4 cyclists, okay? So what I want us to do, actually, pencils, is you're gonna grab 4 colored pens or colored pencils, and make sure you grab a ruler. Go grab a ruler. I mean, get up and go grab a ruler if you don't have one. And then come grab 4 different colored pencils, and you're gonna need to represent all 4. Move, go. Grab 4. Oh, look, there's even a ruler in here. Hold on a second. Okay. You need 4
both directions.
4 colored pencil colors. 4 different colors to represent the 4 cyclists. Heck yeah.
I just realized it's missing
It is really.
ribs.
It's actually
It's like
decaf
Sparky
today.
Fisher. Love it.
Yeah.
4?
4. 4 different colors. That's true.
Gray counts as a color.
And then when you get back to your seat, what you're going to do is you're going to take your 4 different colors and make a box around who is what color. So like I'm doing up on the board with my people. And we're going to make Helen orange. Those are all 4 very distinct colors. Okay? So you've got Dan, Maria, Ryan, and Helen. So make Dan, Maria, Ryan, and Helen all 4 separate colors and box them out with the color or shade over them with your colored pencil, whatever you want. Just make them so you know who is what color, okay? Alrighty.
When you need the big graph, count by 50.
Oh yeah, I have it on here, yeah. So,
In order to fit in
Mhm.
question B, push it up with the contact distance.
oh, that's right. Okay, so which one should we just graph first? Which one is the easiest to just graph because it's kind of given to us? Maria, not Maria. Well, Maria sort of is. Sort of. Which one's even easier than Maria's? Ryan. Ryan's literally gives us the equation. So let's do Ryan's equation first. So I got him in green. So going to your graph. Yeah, it's okay. I'm gonna just add. Sorry guys, let me just edit this real quick. Minor axis numbers, x-axis, y-axis, close. There we go. Okay, I'm going to go along here real quick. Sorry guys, I'm gonna.
Okay. No worries.
That was a really straight line until that end. Wow. Okay. Undo. There we go. Okay, there's our x and y axis, okay? You kind of already are given it because you're given just a box, okay? So X and Y. We're gonna count our X is our hours, is what it tells us already. So hours are down here. And then this is our kilometers. Okay? Hours. We're gonna count every 2 as 1 hour, okay? Oh shoot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. I'm gonna go out to 12. Okay. And then I'm gonna go every 15 for my y-axis. And you'll see why later. But this is gonna be 15, and that means so 2 spaces is 30. This would be 45, 75, 105. I literally have it right here, right here.
You're skipping 135.
Why am I skipping 135?
Well, you're skipping. You're counting by.
Oh, yeah.
But then also skipping.
65, 195.
25, and that gets you to D.
Okay. So you should have enough room for all of these on your y-axis, okay? Make sense? Oh. Everyone good about this? Okay. I have to go back real quick just to see what my color for Ryan was. Okay, he was green. Okay. So, oh, I did the thing. I'll tell you later.
Okay.
So y equals 30x is Ryan, right? So that means where's our x-intercept, or y-intercept, sorry? 0. So Ryan's gonna start way down here. That means for every what, he's going where? For every hour, how many kilometers does he go? 30. Yep. So we can go up here, and that means at, here. There we go. So 2, he's gonna be here. 3, 4, 5. If you guys see me make a mistake, please correct me, because yeah. All right, makes sense? Then I'm gonna draw a line to represent Ryan. Which I can't do a line on a graph. I always forget that thing.
Use your ruler. Dad had this gets cranky and won't let us use one.
Okay. We good? Whoa. I'm gonna go with that. Okay. So now we can go back and let's who do you want to do, whose do you want to do next? Dan? Okay, let's do Dan's next. So, how do we find our slope? Change in y over change in x. So 70 minus 145 over 1 minus 4. What do you get on top? What's 70 minus 145? 75. Gotta check it, sorry. Negative 75, yep. Negative 75 And what's 1 minus 4? -3. What's -75 divided by -3? 25. So his slope is 25. So we know that thus far his is going to look like y equals 25x. But we want to figure out what his y-intercept is. There are like two things we could do. What do you guys think we should do though? One of the ways is what you guys did with your graphs yesterday and your table yesterday. There's another way that we've done where you just use the table. Substitute? Yeah, what are we substituting in? Which point do you want to? 1 and 70. Okay. So we can plug in y is 70. 25 times 1 plus b. What do you get for b? Yeah, 45. Okay? So that means Dan's equation is y equals 25x plus 45. Everyone go with this? Yeah? Okay, cool. I'm gonna erase this work down here. So that's his equation, y equals 25x plus 45. So now we can go to the graph and plot y equals 25x plus 45. So my y-intercept is right here. And then what's my slope? 25 for how many hours? Per 1 hour, right? So 25 plus 45, what do you get? 70. So we're going to say that's like right here. And then add another 25. What do you get? 95, which we'll say is like right there. Add another 25. What'd you get? 120, yeah. 120, which is actually going to be right here. And then what do you get for like 10 hours? Not actually sure if we have it on the graph, just kidding. What do you get for 8 hours? Anyone know? What do you do to find 8 hours? Yes, 245. You plug 8 in for x in your original equation, and you should get 245, which is about, it's like right about where Dan's line is, or Ryan's line is, so. And then we connect all our dots. That's a really bad line, I'm very sorry. Using your ruler, you're going to connect your dots. Okay? Look good so far? We understanding where we're going? All right. Back to our graphs. Or the information we're given. Who do we want to do, Maria or Helen next? Helen. Okay. She started cycling 15 kilometers from Rapid City and traveled 50 kilometers in 2 hours. So what's her y-intercept? 15. So I know I can have, oh geez, y equals 15. What is her slope? Do we know? No. But we can find her slope. If she traveled 50 kilometers in 2 hours, what can we do to find her slope? Her slope's going to be per 1 hour. And if we're given 50 in 2 hours, what can we do? Divide it. And what do you get for her slope? 25. Right? Okay. So we're going to go back to the graph. And we can start at 15. Nope. Undo. Start at 15, right? And we know that in 2 hours she had 50 kilometers, so we can just go up and find 50 kilometers. So 45, 50. So every 2 hours we could say she goes 50 kilometers, right? Would you agree with that? So she starts at 50. Oh, I messed it up. What do I have to do? 15 plus what? To find out where she's at in 2 hours. Plus 50, right? Because she traveled 50 miles or 50 kilometers in 2 hours. So we're going to go 50 more. So 50 plus 15 is, you're going to get what? 50 plus 15? 65, yep. So she'll be right about here, actually. Okay, so we can go 50 more from that for 2 hours. So at 4 hours, where's she going to be? What's 65 plus 50? $115. And then 2 more hours, she'll go 50 more miles. So it's 115 plus 50. $165. Okay, that's like good enough points for this. And there we have Helen's line, right? Okay. Lastly, we need to graph Maria's line. Where does Maria start at? How many miles away from Rapid City does she start? 20. Okay, so we know 20 is going to be our what? Our y-intercept, yep. And then looking at your graph, can you tell what her slope is? What did you say? 20? So if we go, we can look at 20, 0, right? That's the point 0, 20, sorry. 0, 20. And then we're given this point 60, or 260, right? 60 minus 40, or 60 minus 20, we get 40. We're changing y's and we're changing x's. So yes, she goes 20 kilometers every hour, okay? So what's the rest of our equation going to look like? Y equals what? 20x plus 20, okay? So now we go back to our graph. And where does she start on our x-intercept? Or y-intercept? Sorry. 20. So we start about here. And then every hour, how many kilometers does she go? 20. So from 20 to 1 hour, where is she at now? 40. 2 hours, she's going to be at 60, just like right about there. 3 hours, 80. 4 hours, 100. 5 hours, 120. Or, whoops, that should be right here. Yeah. Okay. So now we can get the gist of her line. Mine looks really bad, probably. But there you go. There is all 4 cyclists on one graph. So, now we can go to page 53 and answer these lovely questions together. Oh. So, using our graphs, I'll just stay on this page. And you also have your graphs, should have your graphs on your page as well. So if you open your book up for both pages, you can look at your graph and the questions. So A asks us, who is cycling the fastest? Who's cycling the fastest? Looking at your lines, who is cycling the fastest? What'd you say, Hermione? Ryan. How do we know Ryan is cycling the fastest? Steep. Yep. His line is the steepest, right? So Ryan is cycling the fastest. His line is the steepest. That's what you could do to explain it. You could also write what his slope is. What's his slope? Do you remember? Going back to what's his slope? 30. Yeah. All right. So for A, you can say Ryan is cycling the fastest. You can know because his line is the steepest or his slope is 30. Either are, right? Who's cycling the slowest? Maria. How do we know Maria is cycling the slowest? Her slope is the slowest, yeah. Or it's the least steep of the lines, right? What's her slope? 20. Her slope was 20. So you could also write that as an explanation, okay? So Ryan is the fastest, Maria is the slowest. Everyone good on that? Okay. We're going to go through B, and then I want you to go through C and D as a group, or as like a small group or individually. Yeah, we got time. So, will Ryan pass Dan? If so, when? I need to go back and check my key. Ryan is green and Dan is pink. Okay, Ryan is green, Dan is pink. Will Ryan pass Dan? If so, when? Yours is probably don't pay attention to my graph because it's harder to read than yours. So when will Ryan pass Dan? And how can we know when he does that? Or if he does? Think about cycling, okay? If someone's biking a little bit slower than the other, the other one's gonna pass him, right? How do we know he's gonna pass him looking at the graph? What will that be represented by? When the lines cross, they're in a section, right? How do we find an intersection between two lines? Yeah, Amber. Yeah, see where they meet. But how do we solve for that to get an exact answer? What have we been working on? How do we solve a system of linear equations? I think I heard something. Did you say? Substitution, elimination, or you can solve by graphing, but maybe it's hard to read on your graphs. By looking at your graphs, do you know where they would cross? No, don't look at mine. Mine's really bad. You can't read mine. So it's not right. Looking at your graph, where do Ryan and Dan's lines intersect? Yeah, Drew.
Can you go back to see, for me to see which color is which?
Oh, yeah, sorry. So Ryan is green and Dan is pink. Okay? Ryan is green, Dan is pink. So maybe I should do this. This is Maria and Helen. There we go. Is that helpful? Okay. Anyone have an estimate? Between what? Yeah. Between 210 and 215 kilometers, which is about, if we look, 210, 215, it's about between 8 and 9 hours. So knowing our exact equations, Ryan and Dan's, we have y equals 30x and y equals 25x plus 45x, or plus 45. What can we do to solve for the exact number real quick? Substitution. So we have 30x, which we can substitute 30x in for y, because we know that y equals 30x, and then solve. So we get, subtract 25x, you get 5x equals 45. So where do they intersect at what hour? How many hours? 9. At 9 hours. So part B, will Ryan pass Dan? Yes, Ryan will pass Dan at about 9 hours. Okay? All right, so C and D, go ahead and do those in small groups or on your own. Work through those. You guys have about, I'll give you guys about like 5 to 10 minutes to work on those. And then part E, we've already kind of done, so just write all of their linear equations down there. And then we'll go through C and D together in a second. Alrighty, guys. Everyone feeling good about these? Okay. Part C. Will Helen pass Maria? Yes or no? Yes. Helen will pass Maria. And what was your guys' approximation? About 2 hours, about 1 hour. Yeah. If you do the math and you do the system of linear equations, you'll get 1 hour. Yeah, 1 to 2 hours is for an approximation is where you'll get. Okay? And then will Helen pass Dan? Yes or no? No, why not? Because their slope is the same, therefore they are, what's the word? Parallel lines. Yep. Cool. All right, and then if you guys just didn't write these out and wanted to write them out for part E, Ryan had a equation of y equals 30x. Y equals 30x. Helen's was y equals 25x plus 15. Dan's was y equals 25x plus 45. And Maria's was y equals 20x plus 20. Okay? Wow. Okay? Alrighty. Questions about anything today that we went over today? Everyone feeling good about this? All right, you guys are done for the day. Good job. Project next Friday will be due next Friday. We're going to talk about it next Tuesday, so you guys are going to have all next week to work on it. Remember, we don't have school next Monday, so yay. Yeah, please put your colored pencils back up here. Make sure you put your rulers back behind Hogwarts as well.
Go right now. I'm sure it's
Have a great rest of your day, folks.
Mr.